Using the neutral of a 100 amp subfeed for a three-way light switch at the barn creates a code violation. The neutral conductor cannot be shared between different electrical systems. The 100 amp subfeed and the three-way light switch are considered separate electrical systems. NEC Section 300.3b requires that conductors of different systems shall not occupy the same raceway, cable, box, auxiliary gutter, or other enclosure. To correct this issue, install a separate neutral conductor from the main service panel at the house to the barn panel for the three-way light switch. The separate neutral conductor can be run in the same conduit as the other conductors for the three-way light switch. In addition, do not run the number 12 THWN copper travelers and number 2 aluminum service conductor in the same conduit. Aluminum and copper should not be in direct contact due to the potential for galvanic corrosion. Galvanic corrosion is an electrochemical process where one metal corrodes preferentially when it is in electrical contact with another metal in the presence of an electrolyte. This is relevant when dissimilar metals, like aluminum and copper, are in contact in an environment with moisture. Aluminum, being less noble than copper, tends to corrode. When aluminum and copper are in direct contact and exposed to moisture, the aluminum acts as the anode and corrodes, while the copper acts as the cathode. This corrosion can weaken the connection and lead to failures over time. To prevent galvanic corrosion, avoid direct contact between aluminum and copper. Use approved connectors and fittings designed for joining dissimilar metals. These connectors are often pre-filled with an anti-oxidation compound that helps to prevent corrosion. Keep the connections dry and protected from moisture, which acts as an electrolyte. Regularly inspect connections for signs of corrosion. If corrosion is present, clean the connections and apply an anti-oxidation compound. Consider using a barrier material such as tape or sealant to separate the aluminum and copper. Aluminum conductors require specific installation practices to ensure safe and reliable connections. Firstly, always use connectors and terminals that are specifically designed and listed for use with aluminum conductors. These connectors are typically made of aluminum or are plated to prevent galvanic corrosion between the aluminum conductor and the connector material. Secondly, aluminum is more susceptible to oxidation than copper. When aluminum oxidizes, it forms a non-conductive layer on the surface of the conductor, which can increase resistance and cause overheating. To prevent oxidation, apply an anti-oxidation compound to the aluminum conductor before making the connection. These compounds are typically petroleum-based greases that contain zinc particles or other additives that help to prevent oxidation. Thirdly, aluminum has a higher coefficient of thermal expansion than copper. This means that aluminum expands and contracts more with temperature changes than copper does. This difference in thermal expansion can cause connections to loosen over time, leading to increased resistance and overheating. To prevent loose connections, use torque wrenches to tighten connectors to the manufacturer's specified torque. Also, consider using Belleville washers or other types of spring washers under the connector screws to help maintain pressure on the connection as the aluminum expands and contracts. Fourthly, aluminum is a softer metal than copper, making it more susceptible to damage during installation. Be careful not to nick or scratch the aluminum conductor when stripping the insulation. Use proper stripping tools and techniques. Also, be careful not to over-tighten connectors, as this can crush the aluminum conductor and damage the connection. Fifthly, when terminating aluminum conductors in electrical equipment, make sure that the equipment is listed and labeled for use with aluminum conductors. Some equipment may not be suitable for use with aluminum conductors, and using the wrong equipment can lead to overheating and failure. Sixthly, regularly inspect aluminum connections for signs of corrosion, overheating, or looseness. If any problems are found, correct them immediately. Overheating can cause the insulation on the conductor to melt or burn, creating a fire hazard. Loose connections can also cause arcing, which can damage equipment and create a fire hazard. Seventhly, when installing aluminum conductors and conduit, make sure that the conduit is properly sized and supported. Aluminum conductors are more flexible than copper conductors and can sag or bend if the conduit is not properly supported. This can damage the conductors and make it difficult to pull them through the conduit. Eighthly, When splicing aluminum conductors, use only splicing connectors that are listed and labeled for use with aluminum conductors. Do not use twist-on wire connectors, as they are not suitable for use with aluminum conductors. Ninthly, when terminating aluminum conductors in panel boards, make sure that the panel board is listed and labeled for use with aluminum conductors. Some panel boards may not be suitable for use with aluminum conductors, and using the wrong panel board can lead to overheating and failure. Tenthly, when installing aluminum conductors at doors, make sure that the connections are protected from moisture and corrosion. Use weatherproof connectors and enclosures to prevent moisture from entering the connections. Also, consider using a corrosion inhibitor to protect the aluminum conductor from corrosion. In electrical wiring, a neutral conductor serves as the return path for current in an alternating current (AC) circuit. It is typically connected to the ground at the service panel and carries the unbalanced current back to the source. Here are key aspects of neutral conductors. Firstly, function. The primary role of a neutral conductor is to provide a return path for current from the load back to the source, ensuring the circuit is complete. In a balanced three-phase system, the neutral conductor carries minimal current. However, in an unbalanced system or single-phase circuits, it carries the difference in current between the hot wires. Secondly, grounding. The neutral is typically grounded at the service entrance to provide a reference point and to limit voltage to ground, which helps to protect against electrical shock. This grounding is crucial for safety and proper operation of the electrical system. Thirdly, color coding. In North America, the neutral conductor is typically identified by white or gray color. This color coding helps electricians quickly identify the neutral conductor and ensures correct wiring. Fourthly, current carrying capacity. The neutral conductor must be sized to carry the maximum unbalanced load current. In some cases, the neutral conductor may need to be the same size as the phase conductors, particularly in circuits with significant nonlinear loads. Fifthly, shared neutral circuits, also known as multi-wire branch circuits, can be used to save on wiring costs. However, they must be carefully designed to avoid overloading the neutral conductor, which can lead to overheating and fire hazards. Sixthly, isolated ground. In sensitive electronic equipment, an isolated ground may be used to minimize electrical noise. In such cases, the neutral conductor is isolated from the regular grounding system. Seventhly, NEC requirements. The National Electrical Code (NEC) provides detailed requirements for the installation and use of neutral conductors, including sizing, grounding, and separation from other conductors. Eighthly, safety. The neutral conductor plays a critical role in electrical safety. A properly installed and maintained neutral conductor helps to prevent electrical shock and equipment damage. Ninthly, harmonics. Nonlinear loads, such as electronic devices, can generate harmonic currents that flow through the neutral conductor. These harmonic currents can overload the neutral conductor and cause overheating, so it's essential to consider harmonic mitigation techniques in such systems. Tenthly, testing. Regular testing of the neutral conductor is important to ensure its integrity and proper function. This includes checking for voltage drop, proper grounding, and continuity. For three-way switches, here are 10 technical aspects. Firstly, circuit configuration. A three-way switch circuit consists of two three-way switches controlling a light or other electrical load from two different locations. The switches are wired in such a way that the light can be turned on or off from either switch location. Secondly, traveler wires. Each three-way switch has three terminals, a common terminal, and two traveler terminals. The traveler terminals are connected to each other via two traveler wires that run between the switches. Thirdly, common terminal. The common terminal of one switch is connected to the power source, while the common terminal of the other switch is connected to the light fixture. Fourthly, switch positions. When both switches are in the same position, either both up or both down, the circuit is complete, and the light is on. When the switches are in opposite positions, one up and one down, the circuit is broken, and the light is off. Fifthly, operation. Changing the position of either switch will change the state of the light, turning it on if it was off, or off if it was on. This is because changing the switch position either completes or breaks the circuit. Sixthly, wiring complexity. Wiring three-way switches can be more complex than wiring standard single-pole switches, as it requires careful attention to the connections of the traveler wires and common terminals. Seventhly, applications. Three-way switches are commonly used in hallways, staircases, and large rooms where it is desirable to control a light from multiple locations. Eighthly, four-way switches. In situations where a light needs to be controlled from more than two locations, four-way switches can be added to the circuit. Four-way switches have four terminals and are wired in between the two three-way switches. Ninthly, code compliance. Wiring three-way switches must comply with local electrical codes, including requirements for wire gauge, conduit, and grounding. Tenthly, troubleshooting. Troubleshooting three-way switch circuits can be challenging, as there are multiple potential points of failure. Common problems include incorrect wiring, loose connections, and faulty switches. Aluminum conductors have specific properties and considerations that must be taken into account when used in electrical wiring systems. Firstly, conductivity. Aluminum has a lower conductivity than copper, approximately 61% of copper's conductivity. This means that for the same current carrying capacity, an aluminum conductor must be larger in diameter than a copper conductor. Secondly, ampacity. Due to its lower conductivity, aluminum conductors have a lower ampacity than copper conductors of the same size. The ampacity of aluminum conductors is specified in the National Electrical Code, NEC, Table 310.15b16, which provides ampacity ratings for various conductor sizes and insulation types. Thirdly, weight. Aluminum is significantly lighter than copper, approximately 30% of copper's weight. This makes aluminum conductors easier to handle and install, especially in long runs. Fourthly, cost. Aluminum is generally less expensive than copper, making it a more economical choice for large-scale wiring projects. Fifthly, thermal expansion. Aluminum has a higher coefficient of thermal expansion than copper. This means that aluminum conductors expand and contract more with temperature changes than copper conductors. This can lead to loose connections and overheating if not properly addressed. Sixthly, corrosion. Aluminum is susceptible to corrosion, especially in the presence of moisture and dissimilar metals. To prevent corrosion, aluminum conductors must be properly terminated and protected from moisture. Seventhly, terminations. Aluminum conductors require special connectors and terminations that are specifically designed for use with aluminum. These connectors are typically made of aluminum or are plated to prevent galvanic corrosion. Eighthly, anti-oxidation compounds. Aluminum conductors should be coated with an anti-oxidation compound before being terminated. This compound helps to prevent oxidation and corrosion, ensuring a good electrical connection. Ninthly, torque requirements. Aluminum connectors must be tightened to the manufacturer's specified torque to ensure a secure and reliable connection. Over-tightening can damage the conductor, while under-tightening can lead to loose connections and overheating. Tenthly, code compliance. The use of aluminum conductors must comply with all applicable codes and standards, including the National Electrical Code, NEC. The NEC provides detailed requirements for the installation and use of aluminum conductors, including sizing, ampacity, and termination methods. Conduit, in electrical systems, is a protective tube or channel used to enclose and route electrical wiring. It provides mechanical protection for the wires and helps to prevent electrical hazards. There are several types of conduit available, each with its own characteristics and applications. Firstly, rigid metal conduit, RMC, is a heavy-duty, threaded steel conduit that provides excellent mechanical protection for wires. It is suitable for use in harsh environments and can be used both indoors and outdoors. Secondly, intermediate metal conduit, INC, is a thinner-walled version of RMC that is lighter and easier to work with. It provides good mechanical protection and is suitable for use in many of the same applications as RMC. Thirdly, electrical metallic tubing, M, is a thin-walled, unthreaded steel conduit that is commonly used for indoor wiring. It is lightweight and easy to bend and cut, making it a popular choice for residential and commercial applications. Fourthly, flexible metal conduit, FMC, is a flexible spiral wound steel conduit that is used to connect electrical boxes and equipment in tight spaces. It is not watertight and is not suitable for use in wet locations. Fifthly, liquid-type flexible metal conduit, LFMC, is a flexible metal conduit that is covered with a watertight plastic coating. It is used in wet locations and provides good protection against moisture and corrosion. Sixthly, rigid polyvinyl chloride conduit, PVC, is a lightweight, non-metallic conduit that is resistant to corrosion and chemicals. It is suitable for use in underground and direct burial applications. Seventhly, electrical non-metallic tubing, ENT, is a flexible, non-metallic conduit that is used for indoor wiring. It is lightweight and easy to bend and cut, making it a popular choice for residential applications. Eighthly, conduit size. And conduit size is determined by the number and size of the wires that will be installed in the conduit. The National Electrical Code, NEC, provides tables that specify the maximum number of wires that can be installed in each size of conduit. Ninthly, conduit fill. The conduit fill is the percentage of the conduit's cross-sectional area that is occupied by the wires. The NEC limits the conduit fill to prevent overheating and to make it easier to pull wires through the conduit. Tenthly, conduit supports. Conduit must be properly supported to prevent sagging and damage. The NEC specifies the maximum spacing between conduit supports, which varies depending on the type and size of the conduit. For wire types, THWN is a specific type of insulation for electrical wires. The letters in THWN stand for firstly, T thermoplastic insulation. The letter T indicates that the wire has thermoplastic insulation. Thermoplastic insulation is a type of plastic that softens when heated and hardens when cooled. Secondly, H heat resistant. The letter H indicates that the wire is heat resistant and can withstand temperatures up to 75 degrees Celsius, which is 167 degrees Fahrenheit, in dry locations. Thirdly, W wet location. The letter W indicates that the wire is suitable for use in wet locations. This means that the insulation is moisture resistant and can withstand exposure to water. Fourthly, in nylon coating. The letter N indicates that the wire has a nylon coating. The nylon coating provides additional protection against abrasion, chemicals, and oil. Fifthly, applications. THWN wire is commonly used in residential, commercial, and industrial wiring for general-purpose circuits, lighting, and power distribution. Sixthly, voltage rating. THWN wire typically has a voltage rating of 600 volts, which makes it suitable for use in most electrical systems. Seventhly, conductor material. THWN wire can be made of either copper or aluminum. Copper THWN wire is more conductive and corrosion resistant, while aluminum THWN wire is lighter and less expensive. Eighthly, wire gauge. THWN wire is available in a variety of wire gauges ranging from 14 American wire gauge, AUG, to 4/0 AWG. The appropriate wire gauge depends on the ampacity requirements of the circuit. Ninthly, code compliance. THWN wire must comply with all applicable codes and standards, including the National Electrical Code, NEC. The NEC provides detailed requirements for the installation and use of THWN wire, including sizing, ampacity, and termination methods. Tenthly, installation. THWN wire can be installed in conduit, cable trays, or direct burial applications. When installing THWN wire and conduit, make sure that the conduit is properly sized and supported. The neutral of the 100 amp sub-feed cannot be used as the neutral for the three-way light switch. Installing a separate neutral conductor addresses the code violation and ensures safety. Also, do not run aluminum and copper conductors in the same conduit.